Lesson 3.6, Day 2. The derivative of s with respect to t. S prime equals. As you approach more complicated derivatives, you have to decide what rules matter and what rule am I starting with. I have a cotangent of 2t, that's a composition of two functions, being multiplied by cosecant squared of 2t. This is a composition of three functions. Because they are being multiplied together, and each one is a composition, the multiplying dominates and you start with the product rule. As you progress, you might want to pause and get your highlighters. What we do for the derivative is somebody stays the same times the derivative of the other function. Well, we said there were three pieces to this composition, so I'm going to highlight, and the highlighting helps me keep track I've done this derivative. The squaring is the last thing done in the order of operations, so it'll be the first piece for the derivative. So I'm going to bring the 2 down front, cosecant to the first of 2t, times, now I'm going for the next piece in the chain rule, which is cosecant. The derivative of cosecant is negative cosecant of, and anything that's not highlighted is still left and tucked inside, 2t cotangent of 2t. So that's the middle piece. So again, this goes with the pink exponent. This is for the cosecant. And then I'm going to say times the derivative of the last piece of the composition, which is 2t. Its derivative is 2, so that follows along with this piece. Then I flip it around and I do the reverse. Plus cosecant squared 2t stays the same, times the derivative now of the cotangent of 2t. Cotangent is first, it's the outermost function, so I'm going to say negative cotangent, keep my inside the same, so this corresponds, it's negative, derivative of cotangent is negative cosecant squared of 2t. So that's my derivative of the cotangent. Then I'm going to work my way in to get the 2t, and I'm going to say times 2 at the end to go with that last piece. Once everything is highlighted, you know you've taken the derivative of each of the pieces. Simplifying is next. As I look through, I'm figuring out who's a coefficient that moves to the front. So you look in front of all your trig functions and at the end. Combining them all, we have negative 4 for a leading coefficient. I have my cotangent of 2t here, but I also look down the list, don't go past the plus sign, I have a cotangent here. That means we have cotangent squared 2t. Then I'm looking at cosecant. I have a cosecant here and a cosecant here, cosecant squared of 2t. Everything has been accounted for in the first group up through the plus sign. Then I look for fronts again, negative 1 and constant at the end. So I'm going to say minus 2 times cosecant, cosecant. Put them all together, cosecant to the fourth of 2t. And there's my derivative. The next one, what do we have going on? you have a big, huge bracket, and it's being raised to the 6th power. So that means that the very last thing done is this power of 6. Because that's the last thing done, that tells me that this is going to be a composition rule to start. So I'm doing chain rule to start, but notice inside I have a difference, and I have another group being squared, so another composition within this inside between the difference between the 5x and this. The best way to do these is, again, highlight as you do your derivatives. So the 6 is going first, and I'm going to say s prime equals 6 times 5x minus the quantity of e to the x plus tan to the 4th of x squared being raised to the 5th. That now takes care of that first derivative. Times, because I have a difference, that means the derivative that follows, we multiply the pieces together, has to go in its own bracket because I have a difference inside. I'm going to start with the 5x. It's its own term. The derivative of 5x is 5 minus, all right, now as I progress, I have another composition here. So that means all that follows is going to be linked together because these are all linked inside that grouping symbol. I'm going to start with the 2 and handle the 2 because that's the outermost piece of that group and say 2 times e to the x plus tan to the 4th x to the 1st. Then, as I work my way inside, I am going to say, well, what do I have inside? E to the x, it's part of a sum. So I'm going to say times, I have another group, and this group is only multiplied with the power of 2, because this is all one big group after the difference. I'm going to say e's derivative is itself, plus, and then if I move down, I have two things here. So I'm going to start with the 4 and say 4 tan of x, and then I'm going to go for the derivative of the tan, which is linked to the 4 power, and I got to finish my power rule and put a 3 there. And I would say times, and it's only multiplied by this piece because these are grouped together. So it's secant squared is the derivative of tangent. Close the parenthesis because I notice everything is colored in, so I have accounted for all derivatives, and I'm at the end. This is the derivative of s. And then when they're monster derivatives like that, I would just leave them and not simplify them because at some point you might want to evaluate, and it's better to just leave all the pieces where they are. Back down to our chart. We're going to do more work with the chain rule. This function g right here, y equals, I'm going to write it a little bit differently, g of x times, now this is squaring of f. So it'll be much easier in terms of derivatives if I say function f of x is being squared. Its derivative, in general, is going to be, I start with, well, I look at what I have a big group here tucked inside of a g. So because this is a group inside of a g, that's lending me to start with the chain rule and say g prime of, keep my inside the same, times, and now I'm focusing on the inside. So g's derivative has been done. Let me highlight that. That's been done, and that's this part right here. The next inside, I look at what I have. Well, it's all inside. I have a product inside. I have x linear function, f of x being squared. This is a little composition inside. So because they are two different functions being multiplied, I'm going to say this is a product rule, and a product rule generates two pieces. So I need a grouping symbol because this is being multiplied by the entire product. So we start with a grouping symbol and say x, this one stays the same, times this is the chain rule. So I'm going to start with my 2, bring it down in front, 2 times that f of x to the first, and then I got to finish off that composition because I don't want to leave anything dangling. So the derivative of f of x is times f prime of x. So here's the first as is. This is the derivative of the second. Plus, I still have more to do if I notice this is not highlighted. So the derivative of x is a 1. So I'm going to say, okay, derivative accounted for, times the f of x as is squared. Again, don't do any simplifying, go right for the plugging in, y prime at 3. We have g prime of 3 times f at 3, which is negative 1, squared. So I'm going to say 3 times 1, because I don't want it to get too bulky, so you can do a little bit of work as we're going through. Times the x value we know is 3, and we're going to double the f at negative 3. Well, the f at 3. F at 3 is negative 1, and I'm doubling that, so I'm going to say this is a negative 2, times the f prime at 3, which is 8, plus the f at 3, that was my negative 1, being squared, so it's plus 1 at the end. G prime at 3, go back up to the chart, G prime at 3 is a 2. So I'm going to say 2 times negative 48 plus 1 gives me 2 times negative 47, negative 94 for the value of that one. We did earlier the derivative of e to the x. So d dx of e to the x, we know it's the best derivative of all, it's so easy, is itself. Well, b to the x, b meaning any base number other than e, also starts off pretty easy. It repeats itself, but has a little extra because it's not an e. It's a wannabe e, so it needs a little bit more help, is how I think of it. So we have b to the x times natural log of b for the b to the x derivative. How does that work? F prime at z. I have a base number of 4, so we repeat itself, so I'm going to say 4 to the cosecant of z, and after it repeats itself, we'd say times the natural log of the base is 4, but because it is not just x, there's chain rule. I have to account for the derivative of the cosecant, so that is going to be negative cosecant z cotangent z. Close the parenthesis for that group, which is the exponent, minus e to the 1 over z, because it repeats itself, times the derivative of my exponent, because again, it's not just x, so the chain rule applies, and z to the negative 1 is 1 over z is z to the negative 1, so I'm going to say negative z to the negative 2. So this derivative You can leave it like that. But if you were trying to look and see what happens, I'd bring the negative to the front. I don't have any pieces on the left of the subtraction that kind of go together. So I'm just going to bring those all down. And be very careful with the grouping. Parentheses are key to pay attention to. And then the double negative here is plus. We have a fraction now because I have a negative exponent, so it's e to the 1 over z divided by z squared. And that's my derivative for 15. And I'll do 16 in this space. In 16, I'm noticing I have a quotient. F prime of x equals, we start low. My low function is the square root of 1 minus x to the 4th. And then the d high, this is our new one. So I'm going to say it starts off repeating itself. So there's the 4 to the 2x. I have to do the natural log of the base, which is natural log of 4, times the derivative of the exponent, which is 2. That's the low d high minus high, and then d low. You're taking the derivative of this one as is, not moved up, as is. So as is means it's 1 minus x to the 4th to the 1/2. So its derivative is 1/2. Keep the inside the same to the negative 1/2 times the derivative of the inside, negative 4x to the 3rd. All over low squared, we have 1 minus x to the 4th. And on these problems, if you're looking to make a match for a multiple choice, you have to be careful with who combines and who doesn't. 2 is a constant. It goes to the front. It cannot be combined with anybody else. So I'm going to say 2 square roots of 1 minus x to the 4th times my 4 to the 2x times the natural log of 4. In general, I think it's just better to put your natural logs in one group so that you don't misinterpret who you're taking the natural log of. In this case, it's saying only the natural log of 4 because the parentheses open here and closed here. Minus, and then I look through, I've got a 1/2, that's a constant. I have the negative 4x to the 3rd. So I'm going to change this to plus. Half of 4 becomes 2x to the 3rd times the 4 to the 2x times, and then I'm going to keep this quantity here. It cannot move to the bottom because we have addition. So do not make that algebraic boo-boo. It has to stay in the numerator. 17, we have a particle moving along a line so that its position is this function, on 0 to 5. What is the position of the particle when it changes going from right to left? So there's movement of the particle, and if I'm going right and I'm going left and I have movement, then I want to look at my velocity function. So the first thing I'm going to do is find v of t. 3 is a constant multiplier, so I'm going to carry it along with the derivative of this composition. I have a cosine, and then I have an angle. So there's 2 pieces to this derivative. Derivative of cosine goes to negative sine, but it's a negative 3 sine of pi t over 2. Notice the inside is staying the same. Times the derivative of that inside, which is pi over 2. When a particle changes from moving right to left or left to right, that means it pauses. That means its velocity as it changes direction is 0. Key step. negative 3 pi over 2, combining constants, sine pi over 2t. Well, who would go to 0 of all this group? Only the sine of pi over 2t is eligible to go to 0 because this is a constant. Then I've got to use my pre-calc skills to say the angle pi over 2t has to be what when sine is going to 0. So sine goes to 0. The first spot it goes to 0 is at pi over 2. The next spot it goes to, oops, sorry, I said that wrong. Sine is going to 0, not cosine. So that occurs at 0. Then it occurs at pi. Then it occurs at 2 pi, and so on and so on. I want to keep in mind my domain here. So I'm going to put a comma and kind of wait. T equals, multiply by the reciprocal, so 2 over pi times 0 is 0. 2 over pi times pi is 2. 2 over pi times 2 pi gets me to 4. And if I had done the 3 pi, that would have given me 6, which is outside of the domain. So I'm going to stop after the 2 pi. My t values are 0, 2, and 4. In calculus, what we do to analyze motion is make a sign chart for the velocity, because I need to know rights and lefts. On the sign chart, I put the key times where I am pausing and possibly changing direction, and I'll put my end time here so I don't go too far. From 0 to 2, say if I had a time of 1, we trace back to the velocity. So now I'm going to go back to this velocity function, which is right here, and say if the t is a 1, what's the sign of the velocity function? If t is 1, it's pi over 2. Sine at pi over 2 is a 1. Times the negative quantity means this region is negative between 0 and 2, which means the particle is moving to the left. Between 2 and 4, I would test 3. Sine of 3 pi over 2 is a negative 1, times this negative means the region between 2 and 4 is positive. From 4 to 5, we could say I'm testing 4.5, but since we're ending at 5 and it's inclusive, it's much easier to think, oh, let's test 5, because that is part of the ending interval. 5 pi over 2 is back up top, which means it's a 1, times the negative gives me a negative for that region. And your sign charts will alternate as long as you don't have an even root, a double root, a fourth root, and then we're going to go changing direction from right to left. Right meaning positive, left meaning negative. I see that occurring right to left here at the number 4. So the position would be S at 4. So that would be 3 times the cosine of 2 pi. Cosine of 2 pi is a 1, so it means position at 4 is 3.